Hi there. In this video we're going to have a look at two concepts, the gradient of lines and the y-intercept. So when we're thinking about gradient, we're really thinking about the slope of the line or how steep the line is. I've got a few linear equations here ranging from y equals 3x right through to y equals 1/4 x. And we're going to look at what the gradient looks like and how to work out the gradient. You may have come across these particular formulas here. So rise over run, or change in vertical over the change in horizontal. This is one way of working out the gradient. So we're looking at how the y changes, how the vertical changes over or divided by how the horizontal changes of a line. So let's have a look at some lines, and just by the way, I'm using geogebra.org, which is a fabulous graph drawing program. You can input equations and they'll draw them for you, so you can go and have a little play around with that. But let's have a look at a few lines. So these are PNG files that I've downloaded from geogebra.org. I've got 5 lines here, and you can see just by looking at the lines that there are some lines that are a lot steeper than other lines. So if you imagine you're an ant and you're walking up one of these lines, pretending it's a hill, you'd see that if you look at the black line, that line is really steep. So if you're an ant walking up that hill or that line, you'd get pretty tired very quickly. As opposed to if you were walking up that green line there, which is a lot less steep, which means the gradient of that green line is a lot less than the gradient of the black line. Another thing to note with the gradients or the slopes of these lines is that they're all positive. So we have a positive gradient for all these lines here. That means that if you're going from the left to the right, you're sort of walking uphill. So an uphill climb would indicate a positive gradient. So let's have a look at some other types of gradients. So if we look at these lines here, again, if you are going from the left to the right, it's like we're walking downhill. So these lines all have a negative gradient if you go from the left to the right. You'll notice that if we look at the equation of each line, which we will do in another video, that the number in front of the x is negative. There's a negative there. So that indicates that the gradient of the lines are negative. Although we have negative gradients here, we can still see that the black line is far more steeper than, say, the purple and the pink line. And so you'll also notice that the number in front of the x, so here, it's a lot bigger there, even though it's a negative gradient, than, say, here. So gradient is how steep the line is. So let's work out the gradient. If we go back to this one here, so you see for the green line, the equation is y equals 1/4 x. We're going to use rise over run to calculate the gradient. So what you do is you choose 2 points, definite points that you know the coordinates for. So let me grab a colour. So this point here, that point there is 12, 3. So you go across to 12 on the x-axis and up to 3 on the y-axis. So that's the coordinate, 12, 3. And then there's another coordinate there, 4, 1. So what we do is we make a right-angled triangle, and we look at the rise and the run. So the rise is how much the line rises, or the change in the vertical. So this change here, change in the vertical of that line. So you can see that that is 2 units, and the way that you can work that out is if you look at the y value in each of the points, we have 3 here, and if we subtract 1, that'll give us the rise. So if gradient is equal to rise divided by the run, and using this right-angled triangle here, that's numerically, if I work that out, the difference between those two y values in the coordinate, so 3 minus 1, divided by the run is the horizontal, so the change in the horizontal. So that would be 12 minus 4. So you can see that from the x values of the coordinates, 12 minus 4. So that's over 12 minus 4. So we get 3 minus 1 is 2. 12 minus 4 is 8. So 2/8 is the gradient, which simplifies down to 1 over 4. So you can see where you get 1 over 4 in the equation. So that's rise over run. Let's try it for one of the other gradients, so negative gradient. So if we're looking at this pink line here, I've labelled 2 coordinates already. So we're going to work out the gradient for that pink line. There's rise over run. Now you can just look at the graph and see that the change is a vertical change of 3, but let's just use our points. So the rise comes from the change in the y value. So I've got negative 1 here. If I go negative 1 minus negative 4, okay, so I'm using that y value minus this one, divided by the run, you can see is a difference of 6, but let's use our coordinates, so it would be 2 minus 8. So remember, it's a change in the x values, so 2 minus 8. So that will give me negative 1 minus negative 4 will give me negative 1 plus 4, which is 3, divided by 2 minus 8 is negative 6. So that simplifies to 3 over 6 simplifies to 1/2, and I have negative in the denominator, which I can just put in the numerator there. So the gradient is negative 1/2. So if we look back at the equation, which is in pink, you can see that negative 1/2 is in front of the x. That also indicates the gradient. So gradient is the change in the vertical divided by the change in the horizontal. Let's now have a look at y-intercept. So y-intercept is the point where the line crosses the y-axis. So I've got a few lines here. They all have the same gradient. You can tell because the lines are parallel to one another. So if you have lines that are parallel, they have the same gradient. Now the point where the lines cross the y-axis, all we're doing is we're looking at the y-axis and we're finding those points where the line crosses or intersects the line, the y-axis. So those points there are the y-intercepts. So that point there is actually 5 on the y-axis. This point here I can see is 2. That point, although I've covered it, that is actually 1. This point here is negative 1, and that point there is negative 3. So if we look back at our equations for these lines, you can see where those numbers come in. So I'm looking at the green line here. I can definitely see that that line crosses the y-axis at negative 3. If I look at my formula, there's negative 3 there, or minus 3. If I look at the purple line, I can see that it crosses the y-axis at positive 5 on the y-axis. And if I look at my equation, I can see plus 5 there. So if the equation of the line is in this form, y equals mx plus c, m referring to the gradient of the line, c is actually referring to the y-intercept. So if the equation of the line is in this form, then we're just identifying that number tagged on the end there, and that will be the y-intercept.